Welcome back, everybody, to the Fenton Perspective. This is Solaris BlueRaven standing in for Lorian Fenton, and I'm here with my very special guest, Charles Ostman. Hello there.
Yes, indeed.
All right.
The biological entity is still functioning, sort of.
Very good. Glad to hear that. Hey, that was a great promo with Sean David Morton, by the way. Very nice there, Hawk. That's awesome. Nice stuff. So anyways, what were we talking about before we hit the break?
Oh gosh, several different threads at once. So
Hey,
an example of that parallel processing system reaching kind of a critical mass threshold. But okay, so where I was going to hopefully go, we were talking about being able to store consciousness on an external platform. I was suggesting the intersection of quantum computing and evolutionary computing, and that it's not going to be any one kind of one system fits all, but rather a combination of systems that act like organelles, the way that organelles function in a cell, or that organs function in a body, or that different ganglion sections in the brain composite together to make the entire brain. Something kind of like that is going to be what this emergent form of artificial life, and I'll use that term more precisely here, artificial life becomes, as a way to become the extension of ourselves even after we leave this physical life, contain this body that we're stuck in for the moment. So, okay, so getting back to the world of quantum physics meets biophysics, which is kind of my favorite topic, actually, because I think this is really the secret sauce, if you want to call it that.
Hang on for a second here, Charles. I have one breaking news here just for a real second here. This is from Nighthawk, and it's for this show. Any $75 donation, Hawk will send you a Revolution Radio ball cap. That's pretty cool. So just so you know, everybody, don't you want a hat? Sounds great. All right. And continue, Charles. Just had to mention that real quick.
You know,
Thanks,
if the hat was made out of like copper foil or something, or like a anti-microwave mesh or something, that just an idea.
That's a very good idea. Actually, that's a really good idea. Yeah.
Well, hey, what the heck? What can I say? Okay, so kind of like an RFID proof helmet or something. I don't know. Anyway, so the idea is this: that for folks that particularly sort of look at this larger scheme of things, the area that I think is most interesting to look at is this intersection between biophysics, quantum physics, and what you might call consciousness, or however you want to describe that. Now, up until maybe a decade or so ago, this was kind of more or less in the area of philosophical sort of argument, as it were. And you had a small handful of mostly physicists from around the world, and Dean Radin being one of them. And it just so happens I'm literally a few miles away from IONS, the Institute of Noetic Sciences, which is an organization I very strongly like. I like what they do. And Dean Radin and a group of other scientists have been there for a while. And he's published a series of books, and I have all of them here. But he's probably, as much as anyone possibly could, has kind of pushed the envelope of trying to measure in very precise ways evidence or sort of artifacts of this quantum entanglement mechanism as it affects living things, people and other living things for that matter. Okay, well, now you have organizations, much more traditional, mainstream, hard physics kind of entities out there who are beginning to publish papers on, oh my gosh, look, we discovered that quantum entanglement actually exists in photosynthesis. How interesting. Now, you were asking me off the air, what do I do? Where do I work every day? And actually, I can't say a lot about it because I'm sort of not allowed to. I'm sorry.
Right.
But let's just say I work with plants.
Oh, that's easy.
Yeah, okay. So, and I work with plants, and I work with photons and sort of nanoscale things that happen with plants, and I'll just sort of leave it at that.
Nice.
But what I find kind of fascinating is that, in Phys.org, which is a very well-known publication organization, they're like a very mainstream, big science kind of physics entity. So they published an article back in July saying, wow, look at this, quantum entanglement in living things. Who would have imagined? And they were sort of, not quite that sarcastically, but I mean, they were saying, look, guys, I don't care what your background is, you better look at this because this is real science and this is really happening very fast. And actually, where most of the really work, serious, highly funded, very credible work is going on, at least that is being published, I should point out, is in Europe. So a site you might want to check out is something called PAPETS, PAPETS.eu. And this is the Phonon-Assisted Processes for Energy Transfer and Sensing. That's kind of a mouthful, but what this means is this is a collection of people from all different backgrounds, whether it's medical, neurological research, some people from the botany or botanical world, and of course a lot of physics people, all sort of merging together to look at in various different ways exactly what is measurable or what can be sort of redefined as quantum entanglement related processes. And one of the first publications or one of the first pieces of research that came out along these lines actually came from right here in California, was in this research into the quantum dynamics of photosynthesis. And not to get too far into the sort of obscure area, but the general idea is this. If you look at a chloroplast and see what actually happens in a chloroplast, is essentially like a light sensing antenna, sort of. There's what's called the thylakoid structure. It's a particular kind of photoreactive protein. It's like the front end of the chloroplast system. And what happens is when a number of photons come in, you have to have pairs of photons. In other words, a collection of photons have to show up at the same time or within a few femtoseconds of each other for enough energy, enough sort of phonon kinetics. And a phonon is a kind of a cross between a photon and electron. That's a longer discussion I won't go into right now. But the whole idea is there's a certain phonon threshold that instigates the ionization of hydrogen, which ends up in a bunch of electrons being spewed out. And those electrons then get conducted through the thylakoid, and that's actually what starts the photosynthesis process. Okay, fine. So the interest was an attempt to create a synthetic chloroplast. This actually goes back a number of years now. And this was at UC Berkeley, and what used to be called the synchrotron at Lawrence Berkeley Laboratory. I used to work, actually. And more recently, it became the extreme photon source. And so one of the first things they did with the newly converted extreme photon source was to investigate how to possibly unravel the mysteries of a chloroplast so they could make a synthetic version of a chloroplast. And the reason for that was to, in a sense, look for a new type of biologically driven solar energy. I mean, I'm not going to do this as a Department of Energy finance project. Okay, fine. So how far they got into synthesizing different kinds of nanostructured synthetic chloroplasts, that's a whole separate discussion. But the important sort of secret part of all this, or the secret sauce part of this, was that along the way, they began to recognize that because of the electron spin characteristics of these hydrogen atoms sort of bouncing around, and the fact that they were trying to narrow down exactly how many photons had to be exactly at the same time within a certain volumetric region of space to instigate this ionization of hydrogen, so you can get enough electron flow through the thylakoids, so you can get enough, sort of processes going elsewhere in the chloroplast system to end up producing sugar. It's a long discussion, but the end goal is they said, well, actually there's something happening that we can't quite understand. We're not quite sure why it is, but it's just there's sort of a temporal envelope, this femtosecond domain envelope of time, where it seems like different electrons spinning around sort of behave like they're the same. We can't quite understand what that is, but we know it's there because mathematically it's the only way we can explain what we're observing. So it's kind of a big deal when they started to publish, peer-reviewed papers on the quantum entanglement of photosynthesis. That's like a big deal. This is not, some consciousness guy with a beard and long hair in a cabin somewhere. This is like the very pinnacle of high-end hard physics being financed by Department of Energy to research how they could synthesize a chloroplast. So, it may seem kind of obscure, but there's a reason I'm going into all this, because that sort of paved the way for other areas of living things, be it animal or plant, to be researched in the context of quantum entanglement, having some kind of functionality. So the obvious question kind of leaps off the grid that says, well, if you're observing quantum entanglement in the in the ionization of hydrogen atoms to drive a thylakoid photoreactive protein in plants, I wonder if there might be something like that going in, say, neurons, maybe in the brain. Maybe there's some kind of quantum dynamic that's happening. In other words, most people used to think in terms of neural activity as being confined to the transmission of sodium ions across the synaptical, so the synaptical connectors are like these little fibers that come together, and their endpoints, these little buds on the ends. You have a voltage-controlled membrane, essentially, which allows a certain rate of sodium ions to pass through from one membrane to the next. Well, okay, that's almost like a Rube Goldberg kind of description, but that's generally how it was. That's the way the schematic was seen to be. But for a lot of complicated reasons, people were beginning to recognize that there just isn't enough synaptical interconnects. There just isn't enough sort of analog mechanisms available to represent the scale of complexity and the astonishingly high degree of parallelism that occurs in a sort of holographic process engine that is the brain. So there must be something else in there. We don't know exactly what it is, but mathematically, just to sort of reconstruct this kind of a mechanism, there has to be some other layer of something happening that would make this possible. Mm-hmm. So that's where the quantum physics people, believe it or not, started to, sort of get communicated with the sort of advanced frontier of the neurological sciences world to say, well, could there be an argument, at least just a theoretical argument, for something to do with quantum entanglement and the way these different synaptical systems interact? Well, sure enough, further down the trail, beginning edge of this kind of research is starting to happen. Okay, fine. So I mentioned, D-Wave earlier and quantum computing platforms, et cetera. Okay, so about a month ago, this was like a big deal. The world's first, the publicly, and once again, I have to make this point clear. What's publicly acknowledged through peer-reviewed papers is different than what's really being funded in the background. But so for a publicly acknowledged academic press to publish that for the first time ever, they had quantum entanglement, repeatable, specifically verified quantum entanglement at room temperature in a silicon substrate. That's a really big deal. That I know that sounds obscure and weird and kind of way out there in the fringe. No, that's a gigantic thing. Because if you look at something like the D-Wave system, et cetera, these are all cryogenically cooled, or, you look at helium, et cetera. No. Then they got warmer to liquid nitrogen. Okay, now they're talking room temperature. Room temperature with quantum entanglement as a definable process in silicon. Okay, fine, lovely. Park that in your thoughts. Meanwhile, if you go to this Puppet's, site and look at what they're doing, here you have sort of the best people of these different biological sciences. I'm doing that word 3 times. Biological sciences sort of converging on the best people in the sort of quantum physics world, beginning to recognize, okay, how do we merge these things together? So if you're going to start to talk about things like neural interface, neurological sovereignty, consciousness, being able to store the essence of your consciousness in something other than a physical human being, the way this, as I see it to be, the way this is probably going to be workable is with this sort of quantum domain. It's not just going to be a bunch of ones and zeros on a giant memory platform. It's not going to be a faster, sort of IBM supercomputer. No, I think those are all kind of background noise. The real platform, as I see it, and I think an ever-growing number of people are kind of leaning in the same direction, is going to be in this sort of quantum realm where it's not going to be wires attached to the head. It's not going to be, a chip or something necessarily, although there may be implants that sort of facilitate this process. It's going to be able to recognize the quantum entanglement artifacts of consciousness and be able to convey that into a quantum entanglement-enabled platform. And we're just beginning to see the edge of that happening today. So that's kind of why I wanted to bring that up. Because
I'm glad you did. Yeah. And also, I agree with you insofar as insofar as the neural interface goes, it's all going to be based on signal. It's transmission of signals.
Not just transmission of signals, but the fact that signals can occur in a non-locality perspective. That's kind of an important feature here. In other words, it's kind of like telepathy meets computing. I know it's a really bad way of expressing that. I'm sorry I don't have a better way of putting it into words. But it's not just electrons going through a wire or even photons going through a piece of fiber optic cable. It's more like domains of quantum interaction. I know this is hard stuff to get your mind wrapped around, but this is where stuff is going.
And also, what about the holographic mind? You have to incorporate the holographic brain and, of course, multidimensional states of consciousness, so it gets pretty complex.
Yes, but that's exactly why this is probably the only way it's going to work, because you're exactly right. The brain, the mind is a holographic process engine. That's exactly what it is. So if one wanted to convert this into some kind of like a linear data map or a data grid, it would be ridiculous. It would be hopeless. On the other hand, if one could quantify a holographic realm, and that realm, that domain, in a sense, was a part of a larger quantum entanglement sort of mechanism with something else outside the physical body that's contained in, then all of a sudden, both mathematically and physically, you have sort of an answer to an otherwise unsolvable problem. I think this is where things are going. So as you pursue this genre of quantum computing, and you're going to see it everywhere. I mean, certainly like in the financial world, obviously. You're going to see it in the biotech world, because the next level of supercomputing is going to be exactly this. In other words, by the way, the biggest customers right now for this level of supercomputing, it's in the biotech world.
I should be investing in that.
Well, like I said in the previous segment, if you've got a kid in college or something and you're trying to gently steer them in a direction that's going to at least pay for their college debt, this is probably the area they want to be in. I'm not saying this in a gleeful way. I'm just saying in a practical sense, it is in the biogenetics, pharma, that whole universe. And certainly in the computing sciences, this is where the money's being spent. I think that the earlier model of sort of, I want to be the generic IT guy that's going to make giant websites or something. I think that's completely passe and background noise. Where the sort of AI life world is heading towards, and IT is a piece of that puzzle, it's going to be in this direction in some context. Whatever your personal interest might happen to be, that's a separate question mark. But in a sort of a larger scheme of things, this is where I see the money going, and certainly where the interest is going.
Right. So what are the strongest companies in the AI field right now? I think you mentioned Google, but who do you think?
Yeah. No, well, boy, this gets to be a little bit more of a fuzzy answer, because there's a bunch of entities which are out there kind of quietly doing what they're doing, most of them academic, actually. And what happens is these research groups, they develop their particular flavor of what they think the better version of a particular type of AI might be. And then somebody like Google just comes along and buys them up, essentially. So, I mean, I'm not sure that there's a way to identify what company to buy stock in, or, I wouldn't be the right person to advise in that category. I'm not sure there anybody really is, because these business models are so fluid and so different. In an earlier time, you had companies which would build a physical something, a fancy robot or the latest new drone or something. Or when you look at Oculus Rift, I mean, they just got bought up. Those are the folks with the VR system. So the lifetime between inception and when they get absorbed by the larger entity, whatever that might be, instead of being years, it's like months. In fact, quite often these things, before they even get out of the academic labs, there's already somebody in the background sort of waiting for them, saying, okay, here's a giant check, and go for it. So I'm not going to suggest, because I don't think it'd be appropriate to try to say this is the company to look for.
Okay, that's fair enough. Well, Charles, we're getting ready to wrap this up in, maybe 5 minutes plus or minus in the illusion of space and time. So let everybody know how to contact you, or at least check out your websites. And I know we didn't get to really discuss your business, and I'd like to talk about your business at some point, because we always do this. We get wrapped up in the other stuff, and then we never get into the potatoes of what you're doing.
Yeah. Okay. So what am I doing? What's my day job, sort of thing? So I can't tell you exactly what I'm doing in the lab, but I can tell you in a generic sort of overview. The company I work for and with is called General Hydroponics, and most people think of pot growing or something. And actually, I have nothing against that. In fact, I'm very pro marijuana. I shouldn't just be out there anyway, no matter what. But and it was kind of ironic is that, strangely enough, the marijuana growing industry has kind of propelled the interest in this other more advanced technology quite rapidly. But the direction I'm going in is, if you look at both economic models as well as access to healthcare, as well as sort of the quality of life, at the core of all this is access to bioprocesses, food, the way that we produce food and other biological materials, which up until very recently pretty much came from large meta-scale corporate, factory farms, that kind of thing. I'm suggesting something very, very different. And many other entities are beginning to sort of see the same picture. In the world of hydroponics, and I don't mean just like a pot in your closet, I mean these, sort of much more well-developed kind of systems, when you combine the right combination of nutrients, the right kind of lighting, and that's kind of where I come in a little bit, and some other things that may be more of a discussion. But suddenly you have the option of converting buildings, even inner city urban areas, into what could be fantastically prolific, farms, for better choice of words. So there's a concept that's often referred to as vertical farming. That is taking buildings, literally multi-story buildings, and turning them into essentially botanical factories, I guess, for better choice of words. And this has been done in Japan. It's being done all over, Asia, Korea especially, et cetera. It's being done in various parts of Europe. I think it could be done here. And the benefits for everybody are just spectacular, because many people talk about food deserts, and they talk about, a lot of inner cities where you have horrible unemployment to this very day. I don't care what the government numbers are. The unemployment is still really bad. And you have just economies which are broken. You're not going to get back the economies of a previous era. It's just not going to happen. So is there a new type of economy that might be at least viable in some context? And I think part of that would be the ability to bring the ability to create biological resources, whether it's food or other biological things, into the cities in small to moderate scale, where even moderate types of investments could actually produce really prolific results. It would put lots of people back to work, but much more importantly, it would bring high quality food and high quality medicinal products and other things into close proximity. In other words, we have the ability to harness this resource. And as a sort of a side note, since we're having this horrific drought here in California, and I think it's going on elsewhere as well, this is a way to radically reduce the amount of water that's consumed to produce this kind of high-quality bioproducts.
Excellent. And Charles, we're out of time, everybody. Thank you so much for tuning in. Stay tuned here for